I've been asked to provide another example using half-angle formulas to solve trig functions. So here we are. We're going to work through this example. It should be relatively similar to some of the problems that you were assigned. Uh, so we have cosine of x over 2 minus sine of x equals 0. Obviously, we have a straightforward substitution for this. And that's to replace all this with plus or minus the square root of 1 plus cosine of x over 2. You don't have to memorize these because you always have a trig formula sheet. However, keep in mind that cosine, the half angle with cosine is always plus, and the half angle with sine is always minus. You may also have noticed that I moved sine x to the other side. And that's because I know because we're going to wind up with a square root, I'm going to need to square. So let's go ahead and square both sides. This square root drops away, and we get sine squared of x. At this point, we have 1 plus cosine x over 2 equals sine squared x. Now we need to use trig identities to make sure everything is in terms of one trig function or the other. Well, by our Pythagorean identity, we know that sine squared x is equal to 1 minus cosine squared x. So let's go ahead and do that. Now, at least everything is in terms of cosine of x. This may start to look familiar after you've done a few of these. And now we just need to get rid of our fractions. So we're going to multiply 2 by all of this. So we'll have 1 plus cosine of x equals 2 minus 2 cosine squared of x. And now we simply rearrange to get everything on the same side. Now we have something that is in the form of a quadratic, which means we can factor it. You can use U substitution to factor this, or you can just factor it. This one's not that bad to factor, I don't think. So this is what we get. We get 2 cosine x minus 1 and cosine x plus 1. If you think about this, negative 1 times positive 1 is negative 1. We get 2 cosine x minus cosine x. That gives us a positive cosine x still. So that's all fine. So we'll use our zero product property, set both parts equal to 0, and rearrange. So we get cosine x equals 1/2, and cosine x equals negative 1. We'll go look at our unit circle, or you can look at your unit circle. At this point, honestly, you need to have memorized this. That's sort of the point of all those quizzes where you're supposed to memorize this. Where's cosine of x equal to 1/2? Well, that's pi thirds and 5 pi thirds, and cosine of x is only equal to negative 1 at pi. So here's our solution set, we believe. However, you should always check. So we're going to plug this stuff back into our original equation. So we'll start with the pi thirds. We plug pi thirds in, and it looks like this. Pi thirds over 1/2 is pi 6. So we have cosine of pi 6 minus sine of pi thirds. We know this needs to be equal 0, but we just check these. So cosine of pi over 6 is the square root of 3 over 2. And we're subtracting the sine of pi over thirds, which is also the square root of 3 over 2. So this turns out to be 0. That's outstanding. Now we have, we're checking the 5 pi thirds. So we plug that in. 5 pi thirds over 2 is 5 pi 6. And sine of 5 pi thirds is 5 pi thirds, so that's fine. And that's equal to the negative square root of 3 over 2 minus the negative square root of 3 over 2. So these cancel out once again, and we get 0. And then we'll check our pi. So we have cosine of pi halves minus sine of pi. Well, that's just 0 minus 0, which is 0. So all of these work. So we can say definitively that our solution set is x equals pi thirds, 5 pi thirds, and pi. So this is a relatively standard example of how these things work. This is similar to at least 4 of the problems that you were assigned. So hopefully you'll find success with this additional example.